Good morning, afternoon, evening, whatever it may be when you're watching this. We are going to get into chapter 1.2 today, graphs of functions. The first graph we're going to start out with is pretty simple. It's a y equals x squared graph. And what we're going to do, as you can see, we've got our coordinate plane here. We're going to graph y equals x squared on this coordinate plane. And to help us graph this, I have our xy table over here to the right hand side of our coordinate plane. We're going to choose some points and we're going to graph our equation here. So what I'm going to do is I'm going to choose some points for x, and after I choose those points for x, I'm going to solve for y, which should be pretty simple here because all I'm doing is squaring my x to get to my y. So I'm going to start with, let's see. I'm going to start with -2 on my x. Let me get my pen out here. Okay. So I'm going to start with -2 on my x and -1, 0, 1, 2, and a 3. So -2 squared. If I plug this into my y equation, I'll do it once or twice so you can see exactly what I'm doing. I'm putting -2 in for x here, and I'm squaring it. Okay. Now -2 squared is positive 4. So my y for this value of x of -2 is going to be 4. Now I can do the same thing with -1. So y equals -1 squared. Now -1 squared is positive 1. If I plug 0 in for x, I should get a 0 for y, because 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is actually 9. Okay, so now I have several points here that I can use to graph my equation here, okay, or my function. So if I start over here, I can go left -2, and I can go up 4. And I can put my first point here on my graph. Now I can go left -1 and go up 1, and I'll have my second point on my graph. I can go to 0, 0, put that point on my graph. 1, 1, put that point on my graph. 2, 4, and 3 all the way up here to 9. Now this is a y equals x squared graph, so if you could tell, you know, it kind of mirrors itself over this y-axis here. So if I had plugged in that -3 value here, I would have gotten a positive 9 as well. I'm just going to go ahead and put that there too, so it'll make it easy for me to draw. So it does continue on forever. So what I'm going to do is connect my points as best I can. Obviously I'm freehanding this, so it's not at all perfect. And that's about what my graph looks like. Obviously you use your graphing calculator to graph it. It's going to look a lot smoother than my shaky hand does here. But that is how you graph a function, right? We choose some x points and we find its corresponding y values. We put it on our coordinate plane and we draw it out. Okay? Now we're going to do a couple of these, but the whole goal with this graphing section is to get a complete graph, one that shows the basic shape of the graph and important points on the graph and suggest what unseen portions of the graph will be. So if you look at this graph, it continues in an upward direction on the right and left hand sides, which lets us know our graph increases, right? And you'll see the importance of this in several other examples we have in the lecture of getting that true complete graph. And this is honestly where your TI-84 comes in handy, because sometimes when graphing by hand, if we're just randomly choosing points for our x, we don't encompass the true nature of the graph. So using a graphing calculator where we can zoom out and see what the true end behavior is can be really, really helpful. But before we get there, I want us to look at this next example. So this next example says the number of U.S. adults with diabetes in thousands projected to 2050 is shown in table 1.12. So we have this table here, and it's got your years, your thousands, and it goes from 2015 all the way to 2050. Okay, so A says align the data so that x equals the number of years after 2015 and enter those x values in the L1 list of your graphing calculator. Enter the number of millions of US adults with diabetes in L2. Then we're going to use the graphing command in part B to create a scatter plot of these data points. Okay, so we've got this first year. Before we can put anything in the calculator, we have to align this data. Now the first year that we have is 2015, and X is the number of years after 2015. That means that 2015 will be year 0. 2020 will be year 5. 2025 will be year 10. 2030 will be year 15. 20, 25, 30, and 35. Okay? So essentially all we're doing are taking these values here and subtracting them from 2015 to get their aligned value. Okay, that's very important. If you do not align the data, you will wind up getting portions of the question wrong. Okay? Now what we have to do is we have to enter these values in the L1 and L2 on our calculator. I'm going to show you how to do that by bringing the calculator up and actually doing it. But just in case you're referring back to your lecture notes and you don't want to come all the way back to the video to see how to do it if you happen to forget, I have the screenshots here below this question of how to input everything into your L1 and L2 list. Because the first thing you're going to do is you're going to hit the Stat button, as you can see highlighted here in red. It's going to bring up a screen that looks like this to the right that says Edit, Calc, and Test. We're going to hit Enter on the Edit. And what that'll do is it'll bring up your list here. So you'll have list 1 through 5. And with those lists, we'll just enter in our values. So if you notice, I'll scroll down. I did it for this very specific problem. I entered in my L's here. Right here, I entered in my adjusted L's. And then I also entered in my values for my L2 on the corresponding side. Now your L2 values have to line up with your L1 values. You can't just mix and match however you want to. You need to input the list just as it is, or else you will have some issues. Now the next thing you'll have to do is turn on the stat plot. So what we'll do is we'll hit second y equals, and what that'll do is bring up the stat plot options, and we'll hit enter on plot 1 so that we can come into the list and actually turn it on. It'll probably be blinking off. What we'll need to do is scroll down and put the black cursor on and hit enter to select it. And we need to make sure the stat plot option is selected here in your type. Okay, so type here, you got your stat plot. That's your very first one. That's the one that needs to be selected. Okay, so once I have that selected, I'm going to scroll down to zoom stat. Okay. And I think I just messed that up. So right now we're on our plot. We've got it selected on. What we'll go to next is we will go to the zoom button here. Okay. So we will click the zoom button and we will scroll down to number 9, which is zoom stat, and hit enter on that. What it'll do once you do that is bring up your stat option list. And once that list is brought up, and you click zoom stat, what it will do is it will take you directly to the graph, and the graph will actually have your plotted points on it, and it will graph it perfectly every time. So you don't have to zoom out or anything. It just zooms it perfectly for the statistics entered. Okay. So I'm going to pause the initial version here so I can input. Alright, so here I am at my calculator screen to work it through you directly so you can see exactly how it works. To get to my list, I'm going to hit Stat, and I'm going to hit Enter on the Edit, just like I said. I've got my L1 and my L2 here. I already have my list typed in for you, but all you're doing is you're starting with 0, hitting Enter, going down to 5, hit Enter. Every time you enter in a value, you just hit Enter to bring it on down. Once the lists are entered, we can go second Stat Plot. Make sure your plot's turned on. Mine already is. Like I said, yours might be over here on off, blinking like that. If so, put your blinker on, hit enter. Now your stat plot's turned on. Next we go to zoom stat, which is number 9, and as you can see, your stats are now graphed on your XY axis, your coordinate plane here. And zoom stat graphs it perfectly pretty much every time. So there it is for you. There's your scatter plot. Very, very simple, easy to do with your TI-84 calculator. So we're on to the next example here. It says make a table of values for each function, then plot the points to graph the function by hand. The first function we have, f of x equals 1/2 x squared. Okay, so we have again our xy little plot here that we can fill in, and we can do it the same way we did before. We can go -2, -1, 0, 1, 2, 3, and give us some initial points to graph here and see how well it does. Okay, now these initial points that I choose, -2 through 3 or -3 through 3, however many you decide to choose, aren't always the best ones to choose. But I always usually start with these if I'm graphing by hand and the graph is, relatively small. So if I go through and graph this, okay, I'm going to have to solve for these f of x values. So f of -2 equals 1/2 -2 squared. Okay, so -2 squared is 4. 1/2 times 4 is 2. Okay, so let's look at this. F of -1. Let's see, 1/2 times -1 squared. Well, -1 squared is 1. 1 times 1/2 is 1/2. Okay. Now, if I plug a 0 in here, 0 squared is 0. 0 times 1/2 is 0. That's pretty easy. If I plug 1 in here, 1 squared is 1. 1 times 1/2 is 1/2. If I plug 2 in here, 2 squared is 4. 4 times 1/2 is 2. Now if I plug 3 in here, let's see what we get with f of 3. 1/2 times 3 squared. Well, 3 squared is 9, so I get 9 times 1/2. And let's see, 9 1/2 is basically the same thing as 4.5. So I'm right around that 4 1/2 range. Let's see what we can graph here. So if I'm going to go to -2 and then I'm going to go up 2, I'm going to go to -1 and then I'm going to go to 1/2, which is about right there. I'm going to go to 0, 0. I'm going to go to 1 1/2. I'm going to go to 2, 2. And I'm going to go to 3 and up to 4 1/2. This is going to mirror on the other side as well. -3 and 4 1/2 as well. So I get a parabola that basically looks something like this. And I've graphed it decently successfully by hand. Okay? That one's pretty easy, very similar to the first one we did. Alright, so let's get on to example 2. So in this example, we have f of x equals x over x plus 3. Now, if I go with the same x values here that I've been using in my other examples, -2, -1, 0, 1, 2, and 3. Let's see how this turns out. Okay, so what I'm going to do here is I'm going to plug in each of these values. So I'm going to say, okay, f of -2 equals -2 over -2 plus 3. Well, let's see. -2 plus 3 is 1. -2 over 1 is -2. Alright. So that gives me a point here. If I look at f of -1 here. So -1 over -1 plus 3. 3 plus -1 is 2. So I get a 2 on the bottom and a -1 on top. I get -1/2. I plug in 0 here. I want it with a 0 on top and a 3 on the bottom, which is just 0. If I plug in a 1 here, f of 1 equals 1 over 1 plus 3, which is a 4th. If I plug in f of 2, I get 2 over 2 plus 3, which is a 5th. Sorry guys, my handwriting's not the greatest in the world. And if I plug a 3 in here, I'm having a hard time with 3's. I get 3 over, oops, I messed up the last one, didn't I? Error. Hope one of y'all called me out on that. Like, hey, Mr. Shipes, that's supposed to be a 2 over 5, not a 1 over 5. You are indeed correct. So let's fix that real quick. So f of 3 is 3. over 3 plus 3. 3 plus 3 is, let's see, 3 plus 3 is 6. So I get 3 over 6, which is the same thing as a half. Okay, let's see if we can graph some of these points. Negative 2, negative 2. That was a pretty easy one. Negative 1, negative 1/2. Okay, 0, 0. All right. Let's see, 1 1/4. So not much up at all on that one. 2 2/5, which isn't quite a half. 3 and an actual half. So it looks like I've got a function that maybe does something kind of like this. Okay. Now, if I just choose some points and I graph that by hand, hey, that's what I get. That's what I think it looks like, right? But this is not at all what this function looks like. Okay. So this is the importance here of utilizing your TI-84 graphing calculator. So I'm going to pause real quick and we're going to shift over to the TI-84 and we're going to graph this on the calculator. You can see what it actually looks like graphed. Alright, so we're over here on the TI-84. I'm going to go to y equals, clear out anything that's in there, and our function was x divided by x plus 3. Now I got to put that x plus 3 in parentheses because that entire thing is in the denominator. If you don't, you'll wind up with something that won't even look right. Okay? If it's in the denominator, if you have several items in the numerator, you have to do the same thing. If you have several items in the denominator, you have to do the same thing. Put it in parentheses. I only have one x in the numerator here, so I don't have to worry about it in the numerator, but I do have to worry about it in the denominator with that x plus 3. Now, I like to do a standard zoom. And under a standard zoom, this is what the graph looks like. Now, we kind of graphed this right-hand part here that goes down and then up, but we completely missed this left-hand section over here of the graph. So we actually have two curves for this one graph, and that's not a mistake. That's exactly how this is supposed to look. So if you're just picking points and graphing it by hand without first referring to your main graph on your calculator, there's a good chance that in a complicated graph situation that you could miss an entire section of the graph. So if I were to do this on a test or a quiz, I would probably graph it on my TI first, and then I'd come back over and I'd say, okay, now I know what it needs to look like. I can graph it by hand, and I can take some of these points a little bit further to the left. So some of these negative, say, let's see, the first point I think is like a -4 point, maybe a -5, 6, 7 point to graph this other piece of the graph. Now, another cool feature if you graph it on the calculator is you can go second table, and it gives you all the list of the values, your x, y values. So instead of having to solve them by hand, it gives it to them for you for the common x's, okay, for all the whole numbers of x. And you can scroll and get as many as you care to get. If you notice here, we have an error at -3. Now, if you go back to our function and you remember from chapter 1.1 with the domain, we have a problem in our domain here because we've got a discontinuity problem. So we've got that. If you look at our function, let's see, our x plus 3 in the denominator, we're going to have a problem at that -3 because that'll make a 0 in the denominator. And essentially that's why we have that error show up in our table. Okay. But this is a good way to show you how to graph on the calculator so that if you do have to graph by hand, you have an easy way to check yourself. Alright, so the next question says, graph the functions with a graphing calculator using a standard viewing window. State whether the graph has a turning point in this window. Okay, so we have number 3, which is y equals x to the third minus 3x squared plus 4. And number 4 is y equals 40 over x squared plus 4. So what I'm going to do is I'm going to go to the calculator. I'm going to go graph both 3 and 4 back to back. So I'm not going to refer back to the lecture notes. I'm going to go straight to the calculator, work both of these problems through, and then we'll come back to the notes for number 5. Alright, so let's graph number 3, which is the first thing I'm going to do is go to y equals, and I'm going to hit x raised to the third minus 3x squared plus 4. And I'm going to graph it on a standard viewing window. So when I go to zoom, I can hit standard, and that's your standard viewing window. Your standard viewing window goes from -10 to +10 on your x-axis, and from -10 to +10 on your y-axis as well. Now, a turning point is obviously where the graph turns. So it goes from increasing to decreasing. And we can see two of those. We have one right here at x equals 0, y equals 4. And we have another one here at x equals 2 and y equals 0. So we've got a turning point. The first one, it rises and then falls. And the second one, it falls and then begins to rise. So we have two turning points on number 3. Now, if we come to y equals, take out number 3 and put in number 4. Number 4 is 40 divided by, and I'm going to use a parenthesis for the denominator because there's several items in it. So x squared plus 4. I'm going to close my parentheses. Now I'm going to graph it. I've already got the standard viewing window set up, so there's no problem there. It's still going to graph it on that 10 by 10 range. What I see on this one is that I have one turning point in my viewing range. So that turning point here looks like at 0, 10. So it rises to start with, it gets to that point, and then it turns and falls. So on number 4, I only have one turning point. Alright, now number 5 says graph the given function with a graphing calculator using the standard viewing window and the specified window. Which window gives the better view of the graph of the function? So our function here is y equals -x squared plus 20x minus 20 on -1020 by -2090. So we're going to graph it on the standard viewing window to start with, and then we're going to graph it on the specified interval from -10 to 20 and -20 to 90. And we're going to compare and see which window does the best job of graphing this particular function. So let's get over to the TI calculator. Alright, so I'm going to go to y equals to start with, clear out that old function we had in there, graph our new function, which is -x squared plus 20x minus 20. And we're going to graph this on the standard viewing window. It's already in the standard viewing window from number 4, so we're just going to straight with it. And what we notice is on this viewing window, it almost looks like a straight line. We know it's not a straight line because it's a squared function, but it almost looks like a straight line. Now, I'm going to show you how to enter in that window they gave us. So I'm going to go to the window button here, and my x min is going to be -10. It's already set at -10. I'm just going to click down to my x max. Now, my x max is 20. That's what they gave us. And then I'm going to scroll down to y min. Now, they gave us -20 as our y min, and they gave us 90 as our y max. Now, once I have those values typed in, I can hit graph, and it will keep that window that I just put in for it. And now you notice you can see the entire parabola here. Obviously, this window does a much better job. Alright, now our next question here says complete the table. And it says t, and it gives you some t values, and it says s of t, and it gives you s of t equals 5.2t minus 10.5. Now, you can do this one several ways. You can do it by hand, which means you'll take s of t, and you'll use 12 for t, and everywhere you see a t in this function, you'll plug that 12 in. So you get 5.2 times 12 minus 10.5. Now if you calculate that on your calculator, 5.2 times 12 minus 10.5, you get 51.9. Okay. You would next, so 51.9 would go here. You would next have to do s of 16, which is 5.2 times 16 minus 10.5. So 5.2 times 16 minus 10.5 is 72.7. So that will go here. We will do it for 28 as well. So S of 28, that's 5.2 times 28 minus 10.5. So 5.2 28 minus 10.5. That gives us 135.1. And we can also look at S of 43. So 5.2 times 43 minus 10.5 equals 213.1. Now there are other ways you can do this. You can plug your S of t function into your y equals on your calculator, and you can go second table, and you can scroll down to each one of these individual x values or t values here. Okay, so you could scroll down and you could find when your x is 12, when your x is 16, when your x is 28, when your x is 43, and it'll give you these same values in your table. You can graph the function, and then you can do second calc x value, and you could type in those x values and they'll find it for you as well. This one honestly is straightforward enough where you could just put the numbers in just like we did and calculate it out by hand. Okay, so we are going to go on to the next question, which says data for selected years from 2011 and projected to 2023 can be used to show that the balance of the federal direct student loans Y and billions of dollars is related to the number of years after 2010 X by the function Y equals 130.7X plus 699.7. Now A says graph the function for X values corresponding to 2010 to 2025. Okay, so what we have to do really before we can graph this function for these x values corresponding to 2010 and 2025, we actually have to figure out the x values that correspond to 2010 and 2025. Now, x is the number of years after 2010. Therefore, 2010 would be year 0. And that would make 2025 year 15. So we really want to graph this function from x equals 0 to x equals 15. Okay. Now, I'm going to go ahead and read out parts B and C before we go to the calculator so we know exactly what we're looking for. Now, find the value of y when x is 13 is question B. And question C says, what does this function predict the balance of federal direct student loans will be in 2029? So before we go over to our calculator, we need to figure out the x value that we're going to have to solve for 2029. Well, it's years since 2010. How many years since 2010 have passed to get to 2029? Well, 19. So we essentially want to solve this function for x equals 19. Okay, so let's go over to our calculator real quick and see exactly how we can plug it in, graph it, find these values. Alright, so I'm going to go to my calculator. I'm going to hit y equals. I'm going to clear out this old y equals. And I'm going to type in my new one, 130.7x plus 699.7, and I've got that plugged in. Now, I want to look at my x values from 0 to 15. That's what we determined. So what I'll do is I'll go to my window here. I'll hit 0 to 15, and then I'll do zoom fit, which is, if you scroll down, zoom fit is actually 0, and hit enter. And this is what it looks like. Now, if you go back to your window, what you'll notice is it held the value of 0 and 15, but it changed my y values here to make the graph fit on my y-axis between these ones I held steady on my x-axis. That's why it looks so good here. So, I've got it graphed between 0 and 15. Now, my part B, I wanted to know what my y was when my x was 13. So, what I could do several things. I could do second table, and I could scroll on over here on my x until I get to 13. And I'll notice that my y value here is 2,398.8. I can do that. That's perfectly fine. And I could do the same thing for the follow-up question when it wanted to know the year for 2029, what the value would be. We determined the x value for it was 19. We could scroll down to 19 and get its value as well, 3,183. But let's say you're on the graph. You don't necessarily want to do that. You can do second calc value, and it'll say x equals, we're going to say 13. And it'll say, well, when x equals 13, y equals 23.988.8. So there you go on that one. If you happen to do this same thing, though, for x equals 19, you might encounter this error. So I typed in 19, and it says error invalid. You can see go to, and it'll say it's invalid at this x value of 19. The reason it's invalid is because you chose your x to only go from 0 to 15 on your axis. So if you want to figure out what x is when, or what y is when x is 19, you're going to have to include 19 in your graph. So you can do one of two things. The easy thing to do, honestly, is just to zoom out. So I just zoom out one time, it grabs some more x values for me. I can do second calc, value, x is 19. It's zoomed out far enough that now 19 is included in the graph, and it gives me that y value of 3,183. Either way works. And that's as easy as it is on the graph. Alright, so just to finish it up and to put the answers down for you, find the value of y when x is 13. We found that to be 2,398.8. And what does this function predict the balance the federal direct student loans will be in 2019 or 2029? Excuse me. It'll be 3,183. Now, it's important to put your units behind your answer here. So this is billions of dollars. So I'm going to want to make sure I include billions of dollars behind my answer. It's a big difference between $3,183 and 3,183 billions of dollars. Trust me. All right, that completes our lesson for chapter 1.2. Please go online and complete the homework for chapter 1.2, and I will see you right back here for chapter 1.3.